Let us begin by learning what this lesson is about. 3D and animated plots in Python. Welcome! In this lesson, we explore how to create 3D and animated plots using Python. We will use real data, make beautiful visualizations, and even bring them to life with animation. By the end, you will be able to plot in 3 dimensions and create simple animations. Let me share what you will be able to do after this lesson. What you will learn: how to make 3D plots in Python, where to find and load real datasets, simple ways to animate your charts, some tips to make your plots clearer and more fun. Ready? Let us start setting up. Time to set up our tools. Let us import what we need and keep things quiet by hiding warnings. This cell gets your Python environment ready for 3D and animated plotting. Warnings are turned off so you see only important output. We bring in pandas for data, NumPy for math, and Matplotlib for graphics. mpl_toolkits.mplot3d helps us use 3D plots in Matplotlib. The animation module lets us create moving charts. This extra line makes sure your plots show up in the notebook right after the code. Try running this to set everything up. If it works, we are ready for the next step. Let us now get some real data about the sun to play with. Data setup. We will use the sunspots dataset. Sunspots are dark spots on the sun that change over time. Let us load the data and take a quick look before plotting. Sunspots can help us see both patterns and cycles, which are great for visualizing in 3D and animation. Here we load real sunspot data. We grab the sunspots data using stats models. The data comes in a nice table. Let us see how many rows and columns we have. This shows a quick peek at the top of our data. Each row has the date and how many sunspots happened that month. Practice: can you tell how many months we have in our dataset? Let us start with a simple chart to see sunspot cycles over time. We draw a regular line plot first. X shows time in years, Y shows the average number of sunspots. This line chart lets us see how sunspot activity rises and falls in cycles. Label the axis so the meaning is clear. Give our chart a title that tells the viewer what we measured. Show the plot so we can view it right here. Notice how the sunspot numbers go up and down. Soon, we will make this into a 3D plot. It is time to step into the world of 3D charts. 3D plot basics. We can use Axis 3D from mpl_toolkits.mplot3d to make 3D plots. First, let us try a scatter plot in 3 dimensions. 3D plots help reveal patterns across several variables at once. Let us create our first 3D scatter plot. We start a new figure and say we want 3D axes. Time goes on the x-axis, sunspot numbers on y, and a trend on z. The color shows sunspot level, making it easier to see which spots are high or low. We add labels for all 3 axes so you know what each direction means. Set a clear title to help viewers. Finally, we show the 3D scatter plot. Try dragging the plot with your mouse to see it from different angles if your tool allows it. Let us talk about why 3D can be helpful. What is a 3D plot? A 3D plot adds another axis, called Z, to the usual X and Y. This lets you show patterns that need more than 2 variables. Examples are surfaces like hills, climate maps, or showing cycles over time. Now you know what 3D really means in Python plotting. Let us try a line in 3D. We can twist sunspot data for a cool effect. Here, we make a 3D curve from our sunspot data. We multiply sunspot numbers by a cosine wave to make the pattern circle around in 3D. You will see a twisting shape that makes cycles stand out. Again, label axes so you know what you are seeing. A unique title tells people what this visualization is about. Show the plot to reveal the 3D line. What happens if you swap the axes? Try changing which values go on each axis for practice. Another powerful 3D type is the surface plot. Now we make a 3D landscape or surface. X and Y are points on a grid. Each Z value is the height at that point. Surface plots help us see shapes, valleys, and peaks in data, like a science map. We also add a color bar so the viewer can match color to height. Try using your mouse if you want to spin and explore the 3D surface. This kind of plot is used for weather maps, geography, and science wave data. Charts can move too. Let us animate a line to show the sunspot story over time. Animating a plot. 3D plots are great, but movement makes change clear. Let us animate sunspot history as a 2D line chart first. Animation grabs attention, shows growth and cycles, and is great for reports. Let us create our first animation. This code builds an animated line chart. At first, the plot is empty. As the animation runs, the line grows and shows more sunspot points gradually. This gives a feel for how the data changed over decades. Titles, labels, and axes are all set before the animation starts. The interval controls how fast it goes, smaller means faster. The animation plays inside the notebook for you to watch. Animation tip: try adjusting the speed by changing interval. Can you make it play slower or faster? Animation is not just for fun, it tells a bigger story. Why animate? Animation helps your eyes follow trends, spikes, or drops. It is useful for showing how things change over time, from science to business data. Let us move on to animate a 3D chart next. Now let us animate a 3D plot, building it point by point. This animation brings a 3D scatter plot to life. Each frame shows more sunspot data over time. You can see new points pop up as the years roll by. Clearing the axes each time keeps our chart tidy and avoids overlapping. Use this animation to highlight cycles and bursts. The code shows more data with each step, so you see growth and surprise easily. It can be mesmerizing. Animations like this help people notice patterns and peaks that may get missed in still images. Let me give you some quick ideas to make your charts look great. Extra features: customizing your plots. You can adjust 3D and animated plots, colors, viewing angle, even background. Improving style helps people focus on what matters. Let us practice a few customizations. Let us try 2 quick tweaks: color and perspective. We change the 3D point colors and shape for better contrast. You can spin or tilt the camera with view underscore in it. Try different values for unique views. Changing the color map and markers makes your slide or report stand out. Experiment with 11 asim to set the perfect angle. Try playing with these settings and see what you prefer. Now, when you present your plot, people will be drawn in by your creative style. How would you style this plot for a science fair? Even the best coders run into little issues. Common troubleshooting tips. If plots do not show, try running %matplotlib inline again. Check your spelling of column names and functions. Animations sometimes do not show unless you run notebook cells slowly. Save your figures if you want to keep them. Do not worry if something goes wrong at first. Practice is the key. Let us save your hard work as a GIF file. This saves your animation so you can share it online or add it to a report. You need Imagic or FMPEG installed to export as GIF or video. Check your file folder for the new animation when you finish. Can you find the GIF and open it in your operating system's file explorer? Now, for our mini project, let us visualize weather cycles with temperature data. We fetch a famous temperature dataset and see how temperature changes across days and months. The code processes the data, finds monthly and daily averages, and fills in a big table. A new 3D surface plot shows temperature patterns like waves over days and seasons. Color and height help reveal when it is hot or cold. This kind of visualization helps meteorologists find patterns over time. Share what you discover about the hottest and coldest months after running this. Challenge: try switching the axis or color to focus on a different month or season. Let us take it further and animate the temperature changes month by month. This animation brings the temperature surface to life. Each frame shows the temperature landscape for a different month. With edge lines and color, peaks and valleys become easy to spot. Animating by month helps you see the sweep from coldest to warmest and back. This technique is great for seasonal data or sales cycles too. What other yearly cycles could you plot with this approach? Let us look back and celebrate your progress. Recap: you did it. You have learned how to create 3D scatter plots, lines, and surfaces. Animate charts in 2D and 3D. Use real datasets for scientific and weather patterns. Add extra style, save your work, and solve common errors. Practice idea: try creating a 3D or animated plot from your own favorite dataset. Now you are ready for more advanced plots and sharing your visualizations with the world. Next steps and YouTube. Keep practicing, try different datasets, styles, or variables. Want more lessons? Subscribe and hit the notification bell to stay up to date with Python skill videos. Tell us in the comments what you would like to learn next. Thanks for learning. Your next big plot is just a few lines away.